24 machines working 5 hours can produce 432,000 screw heads per day. How many hours will 30 machines need to work to produce 600,000 screws per day? So this is a problem from time and work, which is a universal topic in middle school to high school math, and it's also a topic from where you can get problems in standardized tests like SAT, GRE, GMAT, etc. And I will show two different ways of solving this problem. And I have personally no preference of one way versus the other, but just to let you know that there could be at least two ways of approaching problems like this. So the first method that I will describe is the method of variation. So what does the method of variation involve? It basically starts with defining the variables in the problem, and then considering what relationship each variable has with respect to the other. So if you look at this particular problem, there are actually three variables of interest here, right? So the first one is M, number of machines. The second one is H, the number of hours. And then the third one is N, the number of screw heads per day, right? And then we have to ask ourselves, what is the relationship between these quantities? And I'll start by basically asking this. So if I fix the number of hours for a given number of hours, if the number of machines M increases, what will happen to N? How will N change? N is the number of screw heads. So by simple logic, if machines are working the same number of hours, if I have more number of machines, then that means I can produce more screw heads, right? So N will increase. So we can write something like this, that N is directly proportional to M, or the other way of saying this is N varies directly as M. And in a similar way, we can ask ourselves, if you're given a number of machines, then if the number of hours H increases, what happens to the number of screw heads? Well, we have the same number of machines, but now they're working for more number of hours. That means, I'll be able to produce more screw heads. So N will increase in this case. And so we can write N is directly proportional to number of hours H. So now if we, combine both of this relationship by joint variation, I can write this relationship. N is equal to K multiplied by MH, where K is a constant, right? And from the very first line of the problem, we are given N, M, and H. So we are basically given N is equal to 432,000, right? And then M is equal to 24, that's number of machines, and H is 5. So from this statement, we can actually evaluate what the constant K will be. So we just plug in those values on either sides of this equation, and we can get K is equal to 432,000 divided by 120, and that comes to 3600. So if we know K, we can actually write this relationship now as N is equal to 3600 multiplied by m multiplied by h. And then this problem becomes really simple. So what we are asked to find is if n is 600,000 and m is 30, m is the number of machines, right? What is the value of h? So that's what the problem asks. And this now becomes a very simple thing, right? You just plug in these values of n and m, and you use this relationship to find what h will be. And after doing the math, h comes as 50 by 9. So the correct choice in this case will be the option C, 50 by 9. So this is one way of solving this problem using methods of variation. The other way of solving this, and this is probably the way many of us are taught in our middle school or high school, is what's called the unitary method, right? And this may be simpler to some, but it depends on what you prefer. But in unitary method, the best way of approaching the problem is basically rephrase the problem in such a way that the variable that you are asked to find, in this case number of hours, is to the extreme right side. So in this case, since it's the number of hours, I'll just write the problem like this. 24 machines produce 432,000 screw heads working 5 hours. So I'm just rephrasing the problem, writing the number of hours on the extreme right side. And now this is unitary method. Unitary method means that we basically bring each variable to 1, right? So we can start with the number of machines. So we have 24 machines, and I bring that to 1 machine. So 1 machine produces, I keep the number of screw heads the same, but what will be the number of hours? Now, will it be 5 by 24? Because I have 24 machines, bring it down to 1. Should I divide by 24? So that's where you have to think a little bit, right? Because what we are saying now is, well, we have 24 machines that produced a certain number of screw heads working 5 hours. But if we bring it down to 1 machine, to produce the same number of screw heads, it has to actually work more hours than 5, right? So this is actually wrong. We can't divide it by 24. So we have to actually multiply by 24. And this is one common mistake when it comes to unitary method, because many think that they will basically apply the same logic, right, to uniformly scale the quantities. So when the number of machines gets scaled by 24, and in this case gets scaled down by 24, the number of hours doesn't get scaled down by 24. It gets scaled up by 24. So that's something that you have to keep in mind. And this is kind of, analogous to considering the relationship which we did in the previous method, right? The relationship between number of machines in this case and a number of hours, which is actually inverse, because if number of machines decreases, the number of hours will increase to produce the same number of screw heads. So since we did this, now we can basically scale up the number of machines. So we have 30 machines, and the number of screw heads is still the same. And when we scale up the number of machines, the number of hours will now go down, because we have more machines working now. So to produce the same number of screw heads, we will require to work lesser number of hours. So we divide by 30 here, and then we can just simplify this. This comes to 4 hours. So next, we basically bring the number of screw heads to 1 because it's a unitary method. So we are basically, first we scale down the number of machines to 1, then we scaled it back up to whatever the problem asked, 30 machines, and now we're doing the same thing with the number of screw heads. So we first scale it down to 1, and when the number of screw heads decrease, now to produce lesser number of screw heads, I need less time, less number of hours, right? So when I scale down the number of screw heads, the number of hours will also get scaled down. So in this case, it's okay to divide the number of hours by whatever the number of screw heads were, right? So in this case, it's 4 divided by 432,000. And then I scale back the number of screw heads back up to whatever the number was given in the problem, what we are asked to find, right? So 30 machines produce 600,000 screw heads working. And since the number of screw heads have now increased, have now scaled up, number of hours should also increase. So that needs to be scaled up as well. So we multiply by 600,000. And then if we simplify this one, we basically get the same result, 50 by 9. So the correct choice will be option C, 50 by 9.